shown here is our next-gen non-chrome epoxy primer. It's a 2:1 ratio, very simple mixing. You'll notice that this is a 3-component chemistry. Typically with epoxies, you have the base, the adduct, and the solvent. This actually is 3-part chemistry. The reason it's 3-part chemistry, it's got superb anti-corrosive properties. Tests very well. As far as spray equipment goes, you can use conventional, pressure pot, whatever you have in the shop. E-stat, of course, that's without saying. Great wet edge. It's very important on a primer that you have a great wet edge for that very smooth surface. This is purely a corrosion package primer. You wouldn't want to use this as a surfacer. We have surfacer options. But certainly with this product, under any pre-treat that's currently on the market, we'll get that exceptional corrosion resistance. This is the non-chrome primer earlier discussed. Like any base, always mechanically shake this and stir it. They don't settle, but they do get thick. So mechanically shake this base until it's a nice homogeneous consistency. A top tip, when you're taking proportions out of the can and you're using a quart container, what I always do is mark it ahead of time, 2:1 in this case. What it stops you doing is guessing, just clean marks. Base first, adduct, and then solvent. So this is where we are. Again, in this case, it's 2:1. 2 base, 1 adduct, 1 thinner, or 1 activator in this case. There's the hardener. So these are easy. These are big mouth cans, so they're very easy to dispense. If you notice here, it is yellow, like a typical adduct. Don't have any concern with that at all. It's not meant to be clear. So, in we go there. Again, up to the preset mark. It saves any guesswork and looking at, and probably overfilling between the ratios. So that's spot on to the mark. We can use this mixing vessel because it's all part of the same chemistry in the kit. And like most activators, if you look at this, it is clear. It looks like just a pure solvent. It's not, of course, but it looks like one. Once it's stirred, we do require an induction time, 15 minutes usually, not a long time. So let's stir it until we get a nice consistency. Now this time you can take viscosities if you wish. This is a volumetric system. However, viscosity is important, and like anything else on the other materials, if you're using part material, write down the activation time so you know that it's still in life. Now the PPS, again, we're back to the 125s, which is very useful filter grade. It'll take out most debris. So you can filter in if you wish and then filter out, whatever your preference, whatever your work process will be. But you certainly got to filter at some point in the mix. Application of this. Again, we're looking for about 1 mil, 1.2 dry film. We're not looking for high film build. We're looking for that closed film coat. This dries remarkably well to a very low profile. This is a non-sand product. So you can go straight on with top coat if you wish. You can denib if you wish. If there's few inclusions, you can denib. But primarily, this is a low film, non-sand primer. And we're going to paint the rest of these panels. So what does a good non-sand primer need? Well, first of all, it needs a good wet edge. It's vital that when you're painting a frame, the overspray generated actually soaks into itself. If we can look, I don't know whether we can catch this, but if we look at the profile, it's actually flat and level. Again, For a non-sand primer, the profile is absolutely critical. With all top coats, it will, to a degree, follow the profile. So the smaller the profile, the flatter the profile, the top coat, it gives a chance for the top coat to collapse and level without real influence of the primer, trying to recover a primer profile. So as we can see with this, an extended wet edge for an epoxy primer, it repairs well, it blows in well, you don't get any furring around the edge, which is typical. And that profile is perfect, a great canvas for any top coat system.